Our group decided to talk about the RAT technology framework. So to start here, the big question for why are these frameworks in place are our digital technologies enhancing student learning, and how are we able to tell as teachers? So to begin here, technology integration frameworks provide a way to gauge the value of technology use in the classroom. So as we saw in our discussion board, there were many different frameworks we could choose from. However, we decided with RAP because we found it was not as popular online from what we found, so we wanted to make sure people understood the framework of this really useful technology integration framework. So RAP was discovered it's a technology framework that was created based on research. They used theories based on technology, and there were some classroom observations that were conducted to figure out what technologies or how integration of these technologies really were enhancing student learning. So the first letter, R, stands for replacement. So replacement involves using technology, but there's not really a difference in student learning. It's more so a technology is taking the place of, for example, a paper and pencil. So with our idea of replacement, looking at this in action, we would claim here were a few ideas you could use to use replacement in the classroom. One is you could add a worksheet to a Google Classroom in order for students to access and turn it in. The student is still doing a worksheet and turning it in. There's no really change to the assignment or level of learning of the student. Same kind of ideas here is you can complete an assignment online using a formative assessment online, whether it's a worksheet online, some sort of format online is taking place of the worksheet. The learning is staying the same, however the tool is changing. I found following an interesting person on Twitter who posted this that's really relevant to this replacement phase. Don't just replace your old resources with electronic versions. You know what's just as boring as a worksheet, an electronic worksheet. So this would be the idea of replacement, where the technology tool is not enhancing student learning. The next framework in this RAT technology framework is the A for amplification. So amplification moves a little bit further up on the spectrum than replacement, and it involves using technology to extend what the students would otherwise be able to do. So it can increase efficiency and productivity. It does not result in any great differences in student learning again. However, it does make learning a little bit more accessible when you're doing something that you want to do in a more efficient manner. So again, for amplification, some ways we found this to be useful in the classroom are you could make a video or animation for students to watch, teach, reinforce, reteach what was learned in the classroom. Having students go on websites that help them practice or learn new skills make this more efficient. Linda had an idea of taking photos of pioneer species and creating a slideshow to show their role in succession, or analyzing data from virtual labs. And I had an idea of collecting and creating data charts on a graphing calculator to amplify the amount of data students can collect when finding the line of best fit in data. So again, all of these tools enhance the ability for students to engage in their learning. However, their learning is not deepening. Our last and final piece of this RAT framework would be the most important piece, transformation, which is the hardest to achieve. So with transformation, lessons tap into the students' critical thinking skills. So it allows the students to reach beyond what they thought they could or couldn't have done otherwise. And it includes collaboration on a bigger stage. This problem solving among the classroom leads to new opportunities for these kids. So I also found a few things as I was researching, that the actual mental work needs to be changed or expanded. The number of variables involved in the mental processes are expanded. The tool changes the organization in which it had been used. New players become involved with the tool's use, and new opportunities for different forms and types of learning through problem solving, unlike the traditional approaches we're using typically in classrooms. So again, some ways you could implement this into the classroom or to be having students make videos to show their learning. This allows them to deepen their processes as they are teaching kids what they know versus just reciting information. Students can also interact with scientists in a webinar. This would absolutely expand communication and it would deepen their thinking skills. Now, the problem in schools right now, our teachers are aiming to implement technology but are struggling to move past this first phase of replacement. So they have all these tools that schools are pouring a ton of money into getting, but they don't know how to incorporate them to create powerful and meaningful learning opportunities that at the same time enhance a student's ability to understand a concept. So, in order to help you understand as an educator how to implement a lesson that reaches this very final phase of the RAT standard, we'll walk through the beginning stages of a lesson and show you how you can enhance the student learning through moving through this framework. So we will start with a lesson on Pythagorean theorem. So our first phase, replacement, would demonstrate Pythagorean theorem. Here's our worksheet, typical worksheet you would see in a math classroom for this, with an answer key attached. Now as a replacement phase, instead as teachers, we decided to put these similar questions on a platform called Quizizz, where students can interact with these questions online and they can submit their answers online. So this would be the replacement phase because it's taking something on paper and pencil, incorporating a technology tool, but it's not enhancing the learning. To enhance this even further to the amplification stage, we could use a platform like the Desmos Graphing Calculator. This platform allows students to increase maybe the complexity of the problems by using, instead of whole numbers, adding in some decimal numbers here, which are resulting in some crazy long answers. So this amplification stage takes a tool that was already in technology and allows students to perform it more efficiently. However, their understanding is not deepening. Now to move to this transformative stage, students could come into a platform like Scratch, which is a coding platform for students, and they could create a program where players play the game, type in 3 side lengths of a triangle, and their program would then explain or say, yes, your triangle is a right triangle, or no, your triangle is not a right triangle. Let's observe what this might look like in the classroom. So what is your side A? I'll hit, it's going to be 3. Side B will be 4. Side C is 5. Is your triangle a right triangle? Shibuya, this is a right triangle. And it drew the triangle right here. So the code that these kids created not only reinforced their knowledge of this formula, but showed that they really understand the use of this formula. It deepened their knowledge and their effectiveness to code and relay information to a broader audience. Thank you for watching our RAT technology integration framework. We hope you learned something.